Hello and welcome back to this course. So this lecture is more like a motivational lecture where we'll be discussing the various applications of deep learning and we'll be talking about how deep learning is used and where it is used. So I won't be covering all the applications, but I'll cover a wide range of them. We'll start with the very famous application, which is called object detection. So I'm pretty sure that most of you have seen this before. So object detection involves localizing and classifying each object in an image. So we have this image, for example, and this image has several objects like a car, a truck, and a traffic light. And a specific object detection framework is localizing each object. So it's putting a bounding box around each object, as you can see here. And at the same time, it's classifying each object. So here we have a bounding box around this car and it's classifying it as a car. Then we have a bounding box here and it's classifying this object as a truck. So this object is also a truck. And this is a traffic light, this is a car, and this is a traffic light. So this is what object detection is. It involves localizing and classifying each object in an image. Another application is generating faces. So this is more into image generation. It doesn't have to be faces, it can be anything. Okay, so here I'm showing you an example of generating faces, and this is basically a deep learning technique or a specific neural network called GANs, Generative Adversarial Networks. So these networks are capable of generating images given a random noisy input. So you draw a noisy input, some random numbers from the normal distribution, for example, and then you give these noisy inputs to your network, and then it generates some images given these noisy inputs. Now, a modified architecture of GANs is called CycleGAN. So these architectures are able to translate images. So in this case, it's an unpaired image-to-image translation. So, for example, we're able to transform a zebra to a horse, summer to winter, winter to summer, horse to zebra, and so on. Okay, so these architectures are very famous nowadays, which are called CycleGANs, and they're very famous for image translation. In particular, unpaired image-to-image translation. We also have face aging, so we can predict how a person will look like after he's grown up. So, for example, here after 60 years old. This is what a person looks like at the age from 0 to 18, and this is what a person looks like at the age 60 plus, so 60 and over 60. And another architecture is called InstaGAN. So this is a slightly modified architecture of CycleGAN, and as you can see, these are the results. Another very famous application is called text-to-image synthesis. So in this case, rather than giving a noisy input to your GAN, you give it a text description, and then from this text description, you generate some images. Okay, so for example, we give the network an input of this bird is blue and white and has a very short beak. So this is the first stage of the image generation. This is the second stage of the image generation. And as you can see, we were able to generate an image that describes this text that we input. So this is a topic called text-to-image synthesis. Another topic is called pixel-to-pixel. So this involves drawing a sketch and then transforming the sketch to a real image. A very famous topic is called image super resolution. So this involves enhancing the quality of the image. We give the image an input of a low resolution image, as you can see here. So this is the low resolution image. And then we teach it how to reconstruct this image back to its high resolution counterpart. Okay, so this is the original image, and this is what the network generated. This is an architecture called SR-GAN, so super resolution GAN. And as you can see, the reconstructed image is very similar to the original image. Okay, so this is peak signal to noise ratio, and this is the structure similarity. These are two matrices to measure how well is a reconstructed image. And this is another paper on image super resolution, which is called SFT-GAN. As I recall, spatial feature transform GAN. So here they're comparing different methods of image super resolution. So this is what they reached to, which is called SFT-GAN. This is the reconstructed image. So if we take this small part of the image, then we're able to see the details of, or the high resolution information of this image right here. Okay, so this is a very interesting topic in convolutional networks, which is called SFT-GAN. Now, all of what we've been seeing previously are applications of convolutional networks, or GANs. Now let's talk about vision language tasks, where you have both convolutional networks and recurrent networks. So one very famous topic is called image captioning. So this involves generating a description in natural language of a given image. So you give this network an image, this image right here, for example, and then it generates a description of this image. So this is called image captioning. And this is just another paper on image captioning, which is called adaptive attention. Basically, it's the same thing. You're generating a description of this image. Now this involves some more details in the RNN architecture, so I won't be going through these details, but basically it's just the same application, which is called image captioning. Now, a slightly more expanded version of image captioning is called dense captioning. So rather than describing a single image with a single sentence, a global sentence that describes this image, what we do is we describe each object in an image. So we apply image captioning not to the whole image, but to each object in an image. Okay, so this is just an extended version of image captioning. So for example, here we have all of these objects detected in the image, and what we're doing is we're describing each object. So for example, here a small bowl of sauce, food on a plate, a glass of water for this object, a cup of coffee for this object, and so on. So this is a topic called dense captioning. Another topic in vision language task is called scene graph generation. So scene graph generation involves predicting the relationships between objects in an image. So we have a subject and a predicate, and we're trying to predict a relationship between these two. So this is called scene graph generation. So you generate a graph describing the objects and the relationships in an image. Another famous topic in vision language task is called visual question answering. So this involves answering a question of a given image. So basically, the network has two inputs. The first input is the question, and the second input is the image. So given the question and the image, we are required to answer this question of the image. So for example, who is wearing glasses? And then we give this image, of course, and we give this question, and the network predicts man for this image, and the network predicts woman for this image. Another example here, we give this network two inputs, the question, where is the child sitting, and this image, for example, and the network predicts fridge, and for this image it predicts arms. So visual question answering is an emerging topic in vision language tasks, where it involves answering a question on a given image. Okay, now let's switch back to convolutional networks. So what we've seen before, vision language tasks, these tasks are mainly concerned with RNNs, with sequence modeling. So they're not really concerned with CNNs, because you can just use a pre-trained CNN or pre-trained object detection network to extract the features from the image and then feed these features to your RNN. So these architectures are more concerned on building RNNs and developing the architecture and framework for RNNs. So there's a lot of CNNs here in this task of vision language task. These are more concerned with RNNs. Yeah, so let's go back to the applications of CNN. So another application is called semantic segmentation. So as you can see, we segment out the objects in an image. So for example, here we're segmenting out the road, we're segmenting out the street, we're segmenting out the traffic lights, the people, the train, and the cars, and all of these objects are segmented out. So basically what we can do later on is just remove these segments out of the image and replace them with other objects. Okay, so this is one application of semantic segmentation. Another exact application of semantic segmentation is called instance segmentation. Okay, so you can think of semantic segmentation as the big hood, as the general application, and now it has some other branches, and one branch of this is called instance segmentation. So it's the same exact thing, but now we're segmenting each instance. So we're leaving the background of the image, but we're just segmenting out each object or each instance in the image. So as you can see here, the background is left. However, each object here is detected and segmented out. By the way, this application is called Mask RCNN. It's a very famous application for instance segmentation. Another application is called image colorization. So in very simple terms, it just transforms a grayscale image to a color image. So it colorizes this grayscale image. And another application is called image in painting. So here we're able to remove some parts of the image, and then we can feed this image with these cropped parts to the network, and then we can get the reconstructed image. So this architecture right here, image in painting, learns to fill out the blanks in the image. So it learns to fill out this cropped part, this cropped part, and this cropped part. Okay, so what we can do later on is, if a person is standing here, we can remove this person. So let's say that a specific object is here, or for simplicity, let's just consider this object as a person. So we can just erase this object or crop it out from this image, and then we can reconstruct it back. Okay, so we can actually remove objects within an image. This is an application called image in painting. Now let's talk about NLP, natural language processing. So of course you can do a lot of NLP with deep learning, and one very famous application is called machine translation. So basically what you do is you translate an input to another domain. Okay, so for example, here we're translating one language to another. We're translating here from English to German. So the English sentence we want to translate is "where do you come from?" and the translated output is "woher kommen Sie?", which means "where do you come from?" in German. So this is exactly like Google Translate. It translates an image to, it translates a sentence from one language to another. Now this uses a seq-to-seq or sequence-to-sequence model. Okay, this application is called seq-to-seq. Basically, you encode the sentence in one LSTM, and then you decode it back again in another LSTM. So you have two LSTMs, one as the encoder and one as the decoder. Now another application of sequence to sequence is called chatbot. Okay, so in this case, it's a question answering task. So here we had a translation from one language to another. Here we have a question, and then we want to generate a reply. Okay, so it's just a question answering task. This is something called a chatbot. So here, for example, the question is, what do you work? And then the reply is, I am an engineer. So we teach the network how to reply a given question. And one of the last applications I'm going to discuss is music generation. So here we're actually able to generate a specific style of music. We give some data to the network. We teach this network on a specific style of music, and then we teach it how to generate its own music. So maybe later I can share with you some videos of music generated from a neural network. This would be very interesting to see. So that's it for the current applications of deep learning. Thank you very much, and I'll see you in the next lecture.